Well, my computer booted, so let's see if anything is recognized. So if I do lspci, I have all my hardware here, and I should see something like a Tenstorrent or like some generic device. So far it's making me nervous. I don't see anything. Maybe this one. Processing accelerators device 1E52401E. Could be that one. I do see my GPU here. And then I also see everything else. So it might be that processing accelerator. Okay, well let's go and make this thing work. So first of all, what did I even get? So I got the Wormhole, which is in this case, let me just zoom in here. Zoom in. Okay. So customize. Just necessary only. Okay. Save. Okay. So I got the Wormhole n150. So it's the Wormhole n150 and n300 PCIe boards are flexible, scalable processors built with 10.6 cores. Okay. Each includes a compute unit, network on chip, local cache, and baby RISC-V core or RISC-V's cores. I don't know how to pronounce it, either RISC-V or RISC-V. Coalescing in powerful data movement through the chip. Wormhole offers superior performance for cost compared to traditional GPUs and broad data precision format support. Okay, so the thing is that it's not cheap. So this is the one I got, the n150d. And you can see it does look like this. So you have the one chip here, and the n300, we won't waste time looking at it, but the n300 is basically the same card, but with all of this filled with the same chip and more memory. So this is probably the memory here, okay, and then this is the core, this is the processing unit. Okay, so basically, yeah, so it's supposed to compete with GPUs, and it can be networked into multi-chip mesh for workstations and servers. Okay, and there's we're gonna explore the software stack, so we're gonna use TT Buddha and TT Metallium. I want to do both. I want to go high level and low level, and then basically, okay, so here we go. So we have definitely the power for this. It's about 160 watts. Supports Ubuntu 20.04. I think 22.04 should be okay too. So yeah, and let's go. So what else is there? What other information? I don't know. It has some RAM. It has like I think 12 gigabytes of GDDR6. But anyway, we're not here for that. We're here for this. So where to begin? I think the first thing we should do is try to install drivers. At least that's what I think. So Wormhole right here. So first of all, we can download a one-pager. Oh, it has more stuff here. So let's take a look at that. Let's just learn this thing. I actually don't know too much. I just got it because I thought it was cool. And I wanted to do something else besides GPUs. I want to be different, right? That's what this channel is about. Okay, so here we go. The n150d is 12 gigabytes of GDDR6 memory, 12 giga transfers per second memory bandwidth. That's basically 12,000 mega transfers per second. So that's pretty fast for a total of 288 gigabytes per second. It does 262 teraflops per second on FP8, 74 on FP16, and then for block FP8, we do 148. Okay, that's about it. The clock speed, this thing is 1 gigahertz, but there's a lot of SRAM in here. That's a crazy amount of SRAM. SRAM is like, I think, the same type of RAM that's in like your CPU's L1 cache that's only like in kilobytes, but this thing is in megabytes. That's crazy. This thing must be pretty fast for what it is. Okay. I'm getting excited now. All right, so doc site. Let's go here. Okay, so let's bookmark that. We'll probably be here for a while. Okay. Let's just go back to reading Wormhole n150d, n150s, yada yada yada, 10.6 processor. This section outlines the system requirements, physical installation instructions, and initial software setup for the Wormhole n150d, n150s, n300d, and n300s 10.6 processor add-on boards. Let's go. So, the specifications and the requirements, so we know about most of this already. We already got this information from the one-pager. And we have the we have the card, so this allows us to connect more stuff. It's SFP ports. Okay, so then data precision format. So this is important for us to know in case once we do some training or inferencing. FP8, FP16, and BF16, BF16, FP32. Okay, are supported. Interestingly enough, BF2, BF4, and BF8 are also supported, and I think this is actually cutting edge. Integer 8, integer 32, uint 8, TensorFloat 32, never heard of that, and vector. Okay, vector float, I guess. Anyway, we'll learn. And here the operating system says now Ubuntu 22.04. Interesting, so I'll trust that. That's what we have. And operating temperature range, okay. Yeah, sure. Okay, hardware installation. Whoop, too late. We did all this. Desktop workstation, we already inserted it. Okay. Yeah, we already did all this. Connecting the power. Okay, so basically we did the right thing, I think, because it seems like it's running. Let's see what else we have. Okay. Software setup. Yay! If we were to just keep going, would we get there? Yeah, we would get there. So let's just click next. Okay, so the Grayskull software setup. There we go. Okay. Software setup. Let's go to the software setup. Okay, welcome to Tenstorrent. This guide will walk you through setting up your 10.6 processors and installing necessary software. Prerequisites. Okay, I think we do have everything here. It's in the computer already. We are definitely on the internet, and we can sudo. Okay. Recommended OS 22.04 LTS, which we have. Okay. Quiet box, unboxing, software. Okay, so to interact with the 10.6 processor, you'll need to install the system level dependencies on your host machine. Important! This starting guide will reference each software utility where the latest version is available. However, each SDK will have its own compatibility matrix associated with each release. Fair enough. Everything's updated all the time. It is strongly recommended to consult each SDK's release compatibility matrix to ensure that you are installing the correct versions of the system software packages. I wonder if that could be made better. Like, I feel like if it's an ecosystem, there should be some like internal version checks between one like library versus the other library that Tenstorrent is like offering in their stack. At least that's what like my train of thought was assuming, but it's okay. Okay, so we need git, wget, and pip, which we already have. I'm pretty sure we have DKMS. That's just for like drivers, I think. And then we will run the Ubuntu version. Okay, so we could just ensure that we have it. I don't think we have cargo anyway, so it's worth running this command. So let's do that. Okay. So that's step one. Let me just... maybe like this. Okay, so it's installing stuff. Maybe it was just worth splitting it like this. Okay, there we go. Okay. So once that's done, we need to install the kernel mode driver ttkmd. So we can just run all these commands here. So let's just do it blindly. It's gonna get cloned to my home directory. Do I really want that? No, I think we can do it into our code. Yeah, let's go to repo, and we'll do all that here. So, okay. Could not find module source directory. Module Tenstorrent not found in directory lib modules generic. Oh no. Is it because... why? Wait a second. Okay, so we have this. We're in ttkmd. We're going to do sudo dkms add dot. Okay, so we already have it. Then we would sudo dkms install Tenstorrent 1.31. Okay, could not find the module source directory. Why is that? Already, I don't know what I'm doing. Okay. Alrighty, let's go look at some documentation. Okay, so we'll just look at the direct documentation rather than the starting guide. So I guess feedback, right? Anyway, let's try to install it from here. Okay, so the driver registers device files name /dev tenstorrent/d. So if we look at basically the dev, udev, or whatever you call it, we should have seen like a Tenstorrent somewhere in here, but we don't see one. Obviously, it goes from TPM all the way down to TTY and etc. So you must have DKMS installed. Okay, you know what? Let's just make sure. Sudo apt install DKMS. Okay, we already have that. And then yeah, we're supposed to be able to clone this repo, right? So sudo dkms add. So we already have that. Oh, it's 1.33. Wait, is it? Oh, we did 1.31. Oh, this needs updating. Okay, that's okay. I think they're moving so fast that they probably. I mean, to be fair, like Git repo is the source of truth, right? For source code, you know. So anyway, so it looks good. It looks like it's built. And then we could do sudo mod pro Tenstorrent. Okay, I mean, nothing happened, so that's good, right? That's a good sign. Otherwise, there would have been some sort of error. Okay, so we're good. We're good. All right, so this one worked. So let's just make a note of that. Works because correct version is used. 1.31 versus 1.33. Okay. All right. Not too bad. One thing at a time. Okay. So then TT firmware file needs to be installed using the TT Flash utility. Okay, to install ttflash, run this command in a terminal. Alright, I need to probably create a virtual environment, and I think it says it right here too. So note, if you are not using a Python virtual environment, you may see an error, externally managed environment when installing via pip. So if you're not using one, right? To resolve this, create or activate a VNV using a tool like pipx. Okay, so I think feedback here is that you should put this message right before that. Okay, so yeah. Okay, so where would I do this? I'll just do it in my home directory. I'll just do Python 3. So then I will probably do something like this in my home directory, Python 3 m vnv tt or tt vnv. Okay. All right, so I'll just do that. Activate it. Oops. Then activate. Okay. So now I have that activated. Do I just straight up run this? Let's do it. Okay. And then we can update the device firmware. To update the Tenstorrent device firmware using ttflash, so we just installed ttflash, or we're installing it right now. Run these commands in the terminal. wget. We're going to wget the framework or firmware file. Then we're going to run ttflash with this firmware passed in as input. And then we had to reboot the system afterwards. If running that command results in an error that says the firmware is too old, enter the following command. So we're supposed to force. But if we have a newer firmware, what happens? Okay. Sure. Let's do it. Okay, so we downloaded it. We ran ttflash, but 404 not found. Uh-oh. Okay, 404 not found. Couldn't download firmware. Box. Okay. As always, you know, developer instincts is to go and get the firmware elsewhere. So TT firmware is probably the place where we want to go. I am guessing we want this one now, the 801700. So 801700. We need 801700 instead. Okay, sorry, I'm like typing with bad posture and angle and everything. Okay, so really it's just replacing it with this. Oops. Okay, let's try it again. This time it should work. Okay. So what do we have here? So it downloaded for sure, got 200. Setup, searching for default sysconfig path, etc Tenstorrent config.json not found. Okay, so couldn't find config in default searches. Okay, so if you need it, either pass it in explicitly or generate one. How do we generate one? Let's see. How do we generate one? I don't know how to generate one. Oh, this could have just been latest FW bundle too. We could have just passed that in. I think the guy should just put that. But anyway. What do we do? What do we do? What does this look like? maybe there's issues here. Link. Okay, somebody knows that already. Okay, that's fine. I don't know. But anyway, I don't know what to do here. Checking Etsy Tenstorrent config JSON not found. Is there something here that tells us how to make a config? Oh wow, this is, jeez. Okay, no, that's not obvious. This whole stack trace was throwing me off. It was exactly this error. Okay, we had to force this thing. All right, let's do it. Force. Okay. It looks like you're running a very old set of firmware, assuming that it needs to be updated. Oh, okay, so wait. So the firmware was too old, which is why it didn't flash successfully. Not that the firmware that we've downloaded is old. I understand now. Okay. Verbiage is strange, but we got there. Okay, so I'm gonna save this. I'm gonna reboot. See what happens. So we're gonna be on this step here. Set up huge pages. So here we go. Okay, so we're back. So let's do huge pages. Huge pages lets your system allocate dedicated memory to accelerate communication with Tenstorrent devices. Set up huge pages by running these commands in the terminal. Okay, let's hope that this works. Okay, install the deb file. Oh, we should also probably activate our virtual environment. Okay, there we go. Did that work? That worked. I see it here. Okay, so then we can just run this. Okay. Then we can just enable it. Okay. And sudo reboot again. Okay, so apparently this is a temporary solution for configuring huge pages. If the above fails, please check the latest available release from TD System Tools. That's okay. We were successful, so we're good. We don't need step 5. That's multi-card configuration, TD topology. Okay, so now install the system management interface, TTSMI, which is kind of like NVIDIA SMI, I guess, their version. Okay, so we'll activate our virtual environment again. Oopsie. Okay, there we go. And we can do Tenstorrent TTSMI. Okay. So once your hardware and system software are installed, verify the system has been configured properly by running the TTSMI utility. You should see an interface like this one. Okay, fingers crossed. So within the TTSMI, you can see device information, telemetry, and firmware. If TTSMI runs without errors, congratulations, you're ready to use a Tenstorrent device. Take note of any host compatibility warnings. Okay, what does that mean though if we do have them? It's okay. So TTSMI. And what do we do? So we should see stuff here, right? So let's expand. And we see it. We see our Tenstorrent n150 here. How do we use this? Toggle dark mode? Ooh, no. Okay, toggle device info tab. 2 telemetry. So we are currently using 500, or well, it's currently clocked at 500 out of 1000 megahertz. Currently 54 Celsius. Okay, sure. Firmware version 8017. Cool. Pretty recent too. Look at that. April 1st. All right. So we are rolling. Okay. So Tenstorrent provides open source software stacks for developing on 10.6 processors. TT Metallium, TTNN to build your own kernels and models. TT Forge, TTMLIR to create and compile optimized graph operations. Each SDK will have its own system dependency requirements and installation process. To help get you started, check out the first 5 things guide, which includes installation steps for TT Metallium. Oh, TT Buddha is deprecated. That's interesting. Tenstorrent has discontinued development and support for the TT Buddha stack. These links are provided for reference and for developers still using grayscale colors. Oh, so we don't need that. Okay, so so we are done. This is it. What was it? Okay, first 5 things guide. Let's do that. Okay, so getting started. TTNN is a user-friendly API for running ML workloads on Tenstorrent hardware. So it's TTNN is a new thing. The GitHub repo for the project is located here. Okay, let's do that. TT Metal. So TT Metal is the one that we want. Looks significant. Okay, so we can run some models already, it looks like. Sure. Anyway, installation environment setups are an installation guide, so we can just run all those, and then we can run a sample model. Okay, let's do it. Let's at least get the environment working. So, how do we do that? We could do simple kernels, API reference, stuff like that too. TTNN, this is the one we want. So install. So these instructions will guide you through the installation of Tenstorrent system tools and drivers, followed by the installation of TT Metallium and TTNN. Okay, we already got that set up. Okay, so this is the compatibility matrix that we're looking for. So we have Wormhole. We have this for sure. Driver, let's go back here. Our driver version is 133 and they never, 131 or above. So, okay, that's good. That's good. TTSMI 3012 or above. We're at where are we at? 3013 up here. Okay, that's good. So we're good. Wormhole. All right. Okay, system level dependencies, so we need all of this. Sure. Let's see actually what's in here. I'm curious. What are they installing? We should always explore that, right? So what are we looking at here? They are installing a bunch of Python stuff. Okay, just development tools, still essential. Okay, adding the required credentials to add the repos in. Okay. Wait, didn't we do the huge pages thing already? Okay, so maybe this is probably in case you missed all this. Okay. Seems harmless. Let's do it. Where is it? Right there. Okay, I'm just going to copy and run it because I trust the process. Okay. After that, what do we do? We should have already done this. I'm pretty confident we've done this. We've done this. We've already flashed firmware. We've already installed. Oh, we're just basically doing everything all over again. Uh-oh. Well, we're just installing dependencies. If apt is smart, it won't do anything silly. Okay. Here's where we want to be. Okay. So, you know what? We're hardcore. We're going to take option 1 from source. Installing from source gets developers closer to the metal and the source code. Let's do that. Okay, option 1, click. All right. Let's just wait for that to finish. But first, clone the repo, invoke the build scripts. We should have just, I think this should have been step 2, but okay. So basically create the virtual environment and you should install this for profiling use. Why not? We should be. And then continue to URL set. Okay. Easy enough. This lib capstone and all that stuff is like, it's used for like things like Tracy, I think. I don't know if they're probably using, I recognize these. These are like the same things that you would need to install for Tracy. But Tracy is like a profiling tool. Okay. Okay, so we could just clone this first while we wait for all this to go. I think. Well, apparently I did need to install stuff, so that's good. I mean, apparently I was missing things. The script seems to be getting stuff, so maybe I should just let it be. What's going on? Why is it red? Red makes me nervous. This seems fine. I think it's fine. Okay. So code repo. Okay, let's do git clone, Tenstorrent ttmetal.git recursive modules. So let's be developers. Okay, so that's gonna take some time. While we're doing that, so it's as simple as doing this, but we had to be mindful and make sure that we are in our virtual environment, which we already are, ttbnd. Okay. Should probably just do this too. What's Doxygen? Forgot what Doxygen. Is it for just docs, right? Yeah, it's just for docs, building docs. Do we need that? So after we have done that, let's just install this in case. I've been tempted to just do it in order. No, let's do it in order. So build metal.sh. So we go inside to ttmetal. We should have build metal.sh, which is already executable. So here we go. Oh no. CMake 3.24 or higher is required. Oh man. Okay. Really. Oops. I want the exact, let's do this one. Binary distributions. Linux x86 64. I guess this one has an auto script. We could just do that. Let's do it. Okay. let's see how bad it's gonna be. Okay, so see downloads. Where are we at? Chmod plus x, cmake that, Okay, so far so good. It looks like it's an automated script. Let's just quit. I accept the license. By default, cmake will be installed in da. Do you want to include the subdirectory cmake da? Saying no will install blah. Yes, why not? Let's just make sure we'll never delete it. What's in here? Oh, it's just this. Oh, okay. Why not just move it? So, okay, so why not just mv cmake, that's it, make dir cmake, that's fine. Let me think. So I'm going to move this to my bin directory on my home directory, and then I'm going to create, I guess, a symlink. Let's see which symlink. I'm going to create a symlink for USR bin CMake to the real one that I have, which is in bin in this directory. Because if I do bin CMake here, I get the right version. So that's what I'm going to do. I'm going to move everything in this directory. So I'm going to mv CMake that to home bin. Okay. And so that's gone. And if I go to my bin, I should see CMake. Cool. Now, I should be able to symlink. Okay, so I think it's ln-s usr. What was it again? USR bin CMake. Okay, we could do that, and then bin CMake. Oh, no. Bin CMake. Should that be sudo? That should probably be sudo. Okay. The file exists. Wait. Hold on. Oh, backwards. This always gets me. Okay. This is it. That would have been bad. Okay, so bin CMake. File is this. Why? I don't even know how to make one. CMake. Bin. Okay. Okay. Let's do this. This is create symlink. Create symlink. I felt like we just did this yesterday. Oh, Linux. It's always this one. Path to file, path to symlink. To create or update a symlink, ln-sf. Okay, ln-sf. Let's just tuck this. ln-sf, because it kept saying exists, so we'll do home bin CMake bin CMake. Okay, and then we're going to do USR bin CMake, and then let's actually sudo that. Oh, that worked. So I did CMake version. Oh, yay, that worked. Okay. Okay. Where was I? Oh, I wanted to build. Oops. I wanted to build metal. Okay. Okay. Back to what we were doing. Repo. PT metal. There we go. Okay, we're back. Okay, build metal.sh. See what happens. Okay. Seems like it's working now. Okay. Maybe it might take some time, so I'll pause the recording. So I got another thing. It says NUMA library not found. And it was just configuring things. Huh. Okay, well, let's see. Let's just search for that. NUMA library not found. Could not find NUMA. Missing NUMA libraries. So, the lack of open MPI. I guess. No, it's a -1. Install lib NUMA dev. Okay. Shenanigans. Okay, sure. Let's try that again. I realized that maybe linking CMake like that was probably not a good idea, because there's like other things that like need to also be registered. Probably was not a good idea. Okay, let's see. There should have been like instructions to how to do it properly, but it's okay. It's totally okay. Anyway. Oh, it's building now. Great. Okay. Let's see how fast it goes. I'll leave the CMake thing alone. It's working. Watch it come back to haunt me later. Well, fatal error already. Why? Why? Let's see. HWLoc file not found. UMD device. Well, okay. Well, at least it's a third-party library, so that means we could search for something, right? So we could search for it. Let's see if there's anything in here. Let's go with hwloc.h. Is that what it was? hwloc.h. No, we want just issue. No. UMD device CPU set HVP hwloc not found. I feel like this is because why? Here we go. This is the person. Why? I don't even know where the hwloc root is. Let's see. Think. Okay, wait. Let's back up here. It's trying to find it in the same directory as probably this thing here, and then LD, what is it? Let's look for LD library switch. So we include all of these things here, but it doesn't have it. So can we find it somehow? Okay, let's do it like this. Open folder. Let's be brave and open it up. Okay, so what are we looking for? We are looking for, in this case, hwloc.h. Do we have it? We don't have it. Do we have, what else? Was it CPU set lib.hpp? Okay, we have that. And let's just install the extensions for C++. Just me being a noob. Yes. I'm just a normal developer. Okay. Please update your include path. Cannot open source file hwloc.h. Well, first of all, I think we should rimraff build. Okay? Then, what I think we should do is, let's do git clean. No. Let's not git clean. Let's just check out a tag. So, what is the latest release? 0.570. Okay, you could totally just download this, right? But I want to learn how to build this. Okay. There may be differences between the latest main and the previous release. Uh-oh. Okay. Okay. Okay, here's what I'm going to do. Here's what I'm going to do. So I have all the dependencies already, right? So I have... Where are we at? I have all the dependencies already. I have everything I need. Well, all I need to do is just clone the repo again. Where are we at? From source. I'll clone the repo again. And I'm going to check out a tagged release. So what is that release here? That is going to be... That is going to be... these are all release candidates. Let me find it. 0.57.0. Not RCs, but the real true thing. Oh, RC60. Okay. Let's do RC60. It's verified to work. Okay. So RC60. Okay. So let's check out. So let's get. We don't need that. Get check out v0.57.0 RC60. Okay. So what do we have changed here? New commits. Oh wow, interesting here too. New commits. Okay. Here's what we're going to do. Let's just remove that again, but this time let's clone it, but don't recurse. Let's clone, and then we'll recurse separately. All right. So, wait, can we clone at tagged branch? Git clone at tag. Git clone specific tag. One branch name. Okay, this one. Okay, so it's gonna be this one. Let's do that. So let's go here. We'll just do that. Provide. What was it again? Branch. Okay, branch v 0.57.0 RC 60. I forgot what the format was already. This one is dash RC60. Okay. Will that work? Oh, silly me. Typo. There we go. And then space. Okay. Okay, I'm cloning that with a tagged release. So technically, I should be able to build just like this one here. If my environment is right. Big if. Okay, so TT metal should be cloned. Now, the instructions just to say build metal.sh. So it's going to configure. Okay, so what do we have here? The C compiler, Clang 17, is not able to compile a simple test program. It fails with the following. Change there, try compile. Ninja, linker command, external, unable to find library LC++, LC++ ABI. CMake /Linux code repo CMake. Okay. Clang 17, we have that. Should we reinstall it? Install Clang 17. Let's do it. Okay, let's just do it in case, right? And then we'll just chmod this. Okay, and then sudo llvm.sh17. And I guess we'll check back. Okay, that's done. So we'll just verify. So we just do clang 17 -- version and we get stuff. Okay. All right, so let's do this again. Build metal.sh. Yeah, I don't know what's so wrong. The C compiler is not able to compile a simple test program. It fails with the following: build, release, CMake try compile. So I upgraded my CMake again. Apparently just an apt update and apt install CMake worked. So I'm guessing I might need to do something different. I think I need to install the dependencies thing again. This is just my feeling. So systems dependency should be where was that? Right there. System levels dependencies. Okay. So I was already up there, so I'll just do install dependencies again. Oops. Sudo install dependencies. So I think that did fail, like where I got like red once. So maybe that's the reason why. Yeah, let's fix that. Oh, they already added this kitware. Okay, I didn't see that before. Okay, a lot of this stuff is so passive that I didn't realize that was going on. Maybe this will fix everything magically. And if we can't get it running from source, we'll just install from wheel, and that's gonna be the releases page. Sure. JQ command not found. So should we apt install JQ? Maybe that's the reason why. Jeez. Okay. I saw that at the very end just now, just because I looked closer this time. Okay, that looked like it went well this time. Okay, let's try it again. That looked like it's working. I think I just needed to properly install my dependencies. Okay, this is good sign. This is making me feel good. Okay, I just needed one more run of properly installing my dependencies. Yeah. Okay, so it looks like we're finally building. But we were in this step before too. And we were missing a hwloc.h file. Actually, since I do have the repo up again, I mean, I have it somewhere here. Can we find it now? Let's see. Let's see if we restart extensions. Oh, this is actually new. This is new. It's not in this this release. So we could be good. We could be in a good state. Maybe it was just the main branch. We'll see. Looks like this release RC60 branch could be okay. That worked. It worked. I think it worked. That's good. So we made it past the build step. We already have this going. We'll install these dependencies for profiling use. Always useful to have. Continue to you are all set. Okay, let's do it. So to verify your installation, try executing a programming example. So first set the following environment variables. Sure, I'll do that. You know what? Let's just make it so. Let's do that. Let's also do, was it run this one? That should probably be not pwbd, but should be home code repo tt metal meal, huh? Maybe because that's where we were at. Okay. I don't know what they mean by PW, but print working directory, but then that would have been right here if we executed the code. So we'll see. Anyway, okay, so source bash rc, and then we can try running a programming example. Okay, so basically if this works, we're good. So module not found, no module name ttnn examples. Why did we mess up our virtual environment? Let's see. ttnn.examples. Where's that at? ttnn.examples. cd ttnn. Is there .examples? No. Oh, there it is. cd ttnn. .examples. Okay. So there should be. Okay, I think I understand this folder structure. There should be build release here, cd build release. So I think they're expecting us to go in here, most likely. Okay, cdttnn. I'm guessing it's all in here too. I actually don't know where to go. I mean, where was the distribution? Like, where did it go? I should have. Installing tt build release lib exec. Okay, to where? To where? Where's our prefix? Shoot. Wait, installing. Okay. So should it have been in build release? Okay. So let's do this. Vim run op on device. What do we need here? This is okay. We can just run this directly, right? Okay, so is it just as simple as Python run? Oh, we need to install this stuff. Okay. Okay. I think I missed something again. Create. Oh. I think this has special stuff. I think they need more details on here. So cat create v.sh. Okay. Okay, this does have a lot of special stuff. I got it. All right. Okay, let's back up. Let's deactivate this. And then let's do create vnv.sh. Why? Module package util has no attribute importer. Did you mean zip importer? No. Deprecated, removed in Python 3.12. Okay, so pyenv install 3.10. What do we have? usr bin Python 3. How about this? Pyenv global 3.10.12. How's that? Pyenv install 3.12 10.12, and then we'll do that, and then we'll try it again. I think it's just because we're using Python 3.12 as a default, and this thing doesn't support it at this point. So we'll use an old Python now. This has been a struggle. Okay, so I got the right version now. Now what happens if I go back and do this? Create vnv.sh. What? But it says there's gonna be a bin in here. We're gonna activate it. I see. Okay, so there should have been a Python environment in here. Okay. Oh, this is messed up. That's the reason why. Okay. Let's do this. I'm going to remove Python env. Okay, and then I'm going to do that again. Okay. We'll just take it. So then I've now learned that this computer is definitely not a computer I'm going to be leaving on all the time. It's pretty loud, I'll tell you that. Yay, it's funny. All directions, you get somewhere. Okay, so I already installed all this. Okay, I'm gonna go back and go to this thing here. Okay, you know what? Let's just color within the lines. Let's just do this. Let's just color within the lines, okay? Oh, I forgot to even activate the thing. Okay, what? Okay, pyenv, wait. Where was that? Right here. Okay. Let's activate the environment. Sure. Python env. Okay, now let's go down here. Let's just color within the lines for once. Let's just follow directions. Okay, here we go. Nothing. Oh, why? lib python 3.12 so1 cannot open shared object file, no such file or directory. Why is that? That's fine. Wait. Something went wrong. Why libpython 312? That's bizarre. 310? What? Is it because we built and linked with the wrong Python version? Is that the case? Did we just screw something up? Python path. Where's our Python path? But it says PWD here. Okay, you know what? Let's just try rebuilding again, but this time with Python 3.11 or 3.10, like the Python that we have right now. We effed something up. We totally effed something up. Okay. Build metal. That should be faster, I think. I could also just totally delete the release directory and build clean too. We'll see. You know what? I'm going to do that. I'm going to do that. Yeah. I'm going to do that. And then maybe build release too while I'm at it. Because okay. Alright, let's do it again. So that's going to take a while. Okay. I rebuilt it. I'm still in my Python environment. Let's try it again. Okay. I should still have all my environment variables. You know what? Do it again. It doesn't hurt. It doesn't hurt. Okay. Here we go. Alright. It works. We did something. That's great. All that. Okay. We got something working. Okay. So, let's do this. Let's first echo out what these variables are. Just, make sure that I'm not going crazy, that it's just setting this to be, it's just setting these environment variables to be the current repo, right? Okay, so I think I'm good for today, to be honest. I'm happy. So I'm going to next time just go over some tutorials here and then go from there. But our device is working now. What did it do? oh, it just created a tensor. That's it. Okay. Simple. Okay. We're good for now. See you guys later.